Hello, everyone, and welcome back for another Wednesday hangout of the Knowledge Bolide crew. We are really happy you joined us here for our 269th hangout in a row. Tonight, we're doing our Meteorite or MeteorWRONG IDs for our Patreon supporters. So I encourage you all to go out to patreon.com/topherspin and learn more about our Patreon memberships there, how you can support us, and how you can get your rock in front of us if that's what you want as well. So this is going to be, we have 4 samples actually we're going to look at with the crew today. These are samples that have been submitted to us. We're going to take a look at them as a crew, and then we're going to summarize our opinions to you guys on whether they are meteorites or whether they are terrestrial samples, or whether, you know what, kind of intrigued about this. You should probably take another step and actually what that next step should be. So that's always the goal, is to really help you guys find one of these things that is actually a meteorite, or at least worthy of passing on to the next level of testing. As always, we're going to have Sue introduce our rock hounders. So Sue, you deal with them, you talk with them, you communicate with them all the time. Tell us we have a bunch of new people today, don't we?
Yes, Topher, we have 4 rock counters today, and they are all new supporters. A few of them have been with us for a few months, but this is everybody's first rock ID. So our first rock counter of the night is Brett. Now, Brett found this rock in Minnesota.
This is, I think, the smallest sample we have tonight. I think we have one of the larger samples and the smallest sample tonight that we've ever had.
That is true. Yes, this one's only 18 grams. It was found on a hillside in an area of native prairie. Brett says there were a lot of small rocks in the area, but there were very few were actually black. He had his metal detector with him, and he said none of the other rocks were magnetic, but this one was. We ask our rock counters to do a few diagnostic tests, just to, rule things in or rule things out. He did say that this obviously, I had already said it was had a strong attraction to the magnet. And when he did the streak test, he said it was a very light brownish gray streak. He also emailed something else to me. I wasn't exactly sure what it meant, but he says that he used a ceramic knife sharpener, which shows dark red when rubbed on hematite. We like to ask our rock hounders to tell us what meteoritic features that they believe they are viewing on their specimen. Brett reported fusion crust, shiny metal flecks, and a shiny metallic center. That's a new one. I haven't heard that
Yeah,
before.
I was just about to ask you how exactly does that work? I mean, we're not giving you a hard time at all. I'm just shiny metal flex, but with a shiny metal center. Okay.
I have the rock counters take a survey, and most of the meteoritic features are ones that they just choose, like the standard regmaglyphs, fusion crust, contraction cracks. But I always leave an other where they can fill it in, and there's always some definitely unique features that I haven't heard of before. And yeah, rocks are awesome. They're all different. So Brett believes that his specimen is an iron meteorite. But I will say all of our rock counters that we're going to be watching tonight, they're all very open-minded. He says that he also believes it could just be a very weathered meteor wrong, possibly magnetite. So I think it's good when they keep an open mind and they're not, we're not killing dreams when we tell
Yes.
them that, it's not a
Yeah.
meteorite. So,
Yeah.
right, Topher.
All we can do is explain what we're seeing. We can't magically change your sample.
Yeah, exactly. So Brett did he did provide 5 photos. 2 of them were unfortunately just they weren't clear enough. But we have 3 really good photos, and we have a video to take a look at.
Yep. So now is the point where we are stopping as a crew to take a look at all these samples. We'll be back with you in 1 second. All right, we have assembled now. We have 4 people. We have Pat, Dave, Allison, and Bruce going to talk a little bit about what they saw in some of these photos and in the videos. We're going to go with the outside first. I'm looking for someone who's going to comment on what we see, maybe fusion crust. Okay, Bruce?
Yeah. It's basically, you can see right in this photo, on the right-hand side, that edge of what's fusion crust is very thick. And an iron nickel meteorite will not have anything anywhere near, it'll like barely be anything, it'll be barely visible. So this is just one thing that tells me it's not a meteorite.
Okay. Or at least not an iron meteorite with fusion crust. So I don't want to speak for you, but yeah, that's I'm glad you pointed out because that was what I was thinking as well. The fusion crust on an iron meteor is more coloration and texture than an actual, something that could chip away like this. Thank you, Bruce. Let me see here. Uh, Allison, were you going to comment on this one as well?
Yeah, I like the one that was titled Crust Top. Yeah, that one.
Hmm.
It's super black.
Yep.
It's very dark in color. So we're gonna ask ourselves, why does this stick to a magnet? And there's a reason why. There are a lot of really dark minerals, like I think the viewer had even mentioned, possibly magnetite or hematite.
Hmm.
And those are dark minerals that do attract a magnet. So if this were an iron meteorite that we were attracting a magnet, we would expect the shiny chrome interior that we see when we break into those meteorites, where this is really a homogeneous black interior.
Yes, I agree with all those.
It's
Excuse me. Thank you very much for that as well. I don't see iron in this at all necessarily. I don't
mm-hmm,
see an iron meteorite like a Sakota Lin or a Campo di Cello or something like that. Um,
mm-hmm.
as we're coming up on about 25 seconds here, he's going to show the side that he was able to work on. And Dave Pinsky, I think you had something to say about or was it Pat? I apologize, guys.
Yeah, no, it was me on that side that he worked on, and perfect. Leave it right there. So, uh, if it's an iron meteorite, that is going to be shining bright, like more like the quarter that's to the right, and it would look like just fresh metal, and that just looks very dark black. It's also very fine grained, and it looks like if it were broken, you would get some conchoidal
Hmm.
fractures on it. So it's very indicative of a magnetite material that that with that uh, characteristic. Anyway,
Okay.
that's what I got.
Cool. Thank you, man. I appreciate it. This is a good little scene here where he's rotating it around in the sunlight. Look at the outside of it, how it has a tiny little bit of the sparkles on it. A little bit of glitter going off a little bit there. And also when he first picks this up and shows it to us. Um, when I see those are not flecks of metal or specks of metal, as he said that they might be. Um, we've talked a couple times about those as being maybe druzy crystals or at least crystal faces of silica minerals. And that's what's catching the light and that's what's gleaming. And it's only popping, it's only um, barely blinking at you. It's not staying lit the entire time you're rotating the stone as a metal speck, a metal flake, a nickel iron metal would inside a chondrite or inside anything a chondrite. Pat, can I come to you for some
Yeah,
feedback?
Tupper, I completely agree. The little speckling reflections that we're seeing on the outside, those are likely to be very, very tiny crystal faces. This is obviously a very fine-grained rock, and nothing in there that looks like a chondrule. And the interior where he's worked it has kind of a sort of a metallic luster, but it's a very dark metallic luster. And the final thing is, if this were a nickel iron meteorite, it would jump to that magnet, where here it looks like it sort of barely touches on it. So this may well be a igneous rock, cooled quickly, small crystals, but not a meteorite.
Awesome. Thank you
Thank you.
very much, Pat. Appreciate that. We're actually seeing the scratch test done here. And if it was magnetite, I think, well, I don't know. It's hard for me to say, but I would expect to see a lot more of a mark on there myself. Um, but yeah, I'm not seeing anything on this that's really grabbing my attention that I'd be like, hey, let's move this up and take some more time. All right, actually, having looked at your sample and talked about it as a crew, we've all come to the conclusion that there's really not much need to spend more time on this one. No thin section, no more testing. It looks like an interesting stone, but a terrestrial stone, not an iron meteorite for sure. So hopefully, Brett, that gives you a little bit of relief on this one, and you can move on to your next find. We are going on to Meteorite or MeteorWRONG number 2. Sue, who do we have?
We have another new supporter, Kevin. Kevin from Mississippi, or at least that's where he found his rock. We always communicate things in grams, but I forgot to change it this time. So about 7 to 8 pounds. He found it in his backyard in Van Cleve, Mississippi, which is slightly inland from the Gulf Coast to where it's sandy beaches and all that. He found it in his backyard in the grass near a severed pine tree. He found it when he noticed a downed tree in his yard. He cut the grass the week before. He had never seen the rock there before. The only rocks he has in his yard are the gravel in his driveway. So it was something that was just really out of place, and it's what I think why he wanted to get it checked out. Kevin did perform his diagnostic tests on camera, which we always appreciate. There was no attraction to the magnet, and he said that the specimen left behind a white streak. All right, so we always ask our supporters to let us know what meteoritic features they see. Kevin reported fusion crust, magmaglyphs, contraction cracks, chondrules, and shock veins. I did ask him what he thought the meteorite was. We always like people to take a guess. Kevin didn't take a guess. He said he'd rather let the experts theorize what it was. He said he hasn't the faintest idea, other than he was really fairly certain that this fell out of the sky and broke a pine tree and when it landed in his yard.
Well, give us a minute as a crew to take a look at it, and we'll be right back with you. All right, we had a lively discussion, and we realized that this rock is not the same rock on one side as it is the bottom. This is a unique sample. We have like 3 people with their hands up, plus I have some stuff to say. Let's take a look at these pictures together real quick. And it is a very, very interesting sample. One of the first things that someone says, wow, it looks more like a lunar than it does a chondrite. So trust me, we're going for you guys. We want you to have something. Well, look at this opposite side here. This is definitely not similar to the side we saw previously. In fact, when we first saw this, Chris Monk was thinking, wow, it really resembles obsidian. It has an obsidian look to it. And then we flipped it over to this side and we're like, wow, that side does not look like obsidian, but it looks like, Pat will get into it later, what he thinks it may be. It looks like it may have some breccia. These are all things that the crew and I discussed. And now we're going to have a little bit of reporting with you. Allison, would you start us off with your initial impressions, please?
Yeah, the viewer mentions both contraction cracks and shock veins as suspected features in this rock. And I just want to really quickly throw out some differences between those two terms. Contraction cracks are things that we see in the fusion crust as it cools. It contracts and cracks. And shock veins we sometimes see those out in the crust or the outside part of the meteorite, but they're more often something that we're noticing inside of the meteorite, melted shock veins. So now that we understand those two terms, I want to talk about them a little bit more and say that this piece has a lot of really sharp edges.
Yeah.
And the lines that we see, those white lines that we see across it, are not shock veins. Again, addressing the outside of the rock in that manner. Mm-hmm. And then there are some big cracks in this sample as well. And those cracks are quite large. In fact, too big to be contraction cracks if that were the case there. So no shock veins, no contraction cracks that I see that look meteoritic in any way.
Awesome. Thank you very much. I have it paused here. I want to show off two things. I'm going to steal something from Pat so I can sound smart. Um, I was trying to tell the crew, like, hey, man, if you look at this from a certain angle with your rock hound lenses on, you can see chondrules. You can see round formations in there. Isn't that what I'm supposed to be looking for? Um, Given the size of this sample, those cannot be chondrules. Chondrules are a lot smaller. This would be yeah. So the scale of it is off. I want to go to 40 seconds real quick. We talk about conchoidal fractures being a giveaway of leaning towards, if not a dead giveaway for terrestrial. If you notice, this is a prime example of a conchoidal fracture. And we had someone pointed out, I don't know who it was, so I can't give them credit, but watch how it catches the light at like 40, right down here in the corner. Look at that, right there. That entire thing, this entire conchoidal fracture right here would not exist on a meteorite. Ben, can I come to you for your opinion, please, sir?
Sure. Just as you pointed out, that conchoidal fracture also is a hint that it's something igneous that cooled pretty rapidly. Uh, and that's what all those little silicated lines are going through it. And what looks like might have been chondrules at any point, they're really not rounded enough and they're way too large.
Yeah.
Uh, it looks igneous.
Okay. Sorry if I stole your comment there. I knew someone was talking about them being too large. And if it's about chondrules, I knew it was going to be probably Pat. When you look at this sample, though, like here, this is a great example. Allison was saying, we don't like these sharp angles. We don't like these fracture points. You're not going to see these as much on meteorites. And the surface of it just looks wrong. The way it's reflecting light, the luminosity, I think is the term someone used. Pat, do you want to bat us home while I play the rest of the video for us?
Yes, sir. And if you wouldn't mind restarting
Yeah.
at the beginning of the video, because it shows us a couple of very valuable things. So there's in the lower left there's the conchoidal fracture right below his thumb. And then
Wait, where is that? I'm sorry.
You're almost there.
I'm just going to let it play. You tell me when to pause it.
Okay. Yeah, stop right there and look kind of across from his third finger. There's it's kind of a bean-shaped conchoidal fracture on the edge. That right there. Yes. So that shows that it's a very glassy, very, very fine grained thing. And then as we play the video here, look at how large, flat, and glassy those surfaces are.
Yes.
That's not something we'll see in meteorites. And Allison said, we don't really like sharp edges. Meteorites have very rounded, soft shoulders. Now, the one thing that is wild about this rock is this is obviously a fractured side, a more recent fracture, but the other side shows lumps and bumps and such, and I think that's just weathering. So I suspect this is obsidian-like, maybe right on the edge of it, cooling super fast to cooling a little slower and building some crystals. But then these areas that are not black are a sign of weathering, where it's been exposed to freeze-thaw cycles. And now it's a really cool rock, but
it's very interesting, isn't it?
Yeah. And that's what I have. Thank you.
Thank you very much, Pat. I appreciate it. Chris Monk, if you don't mind.
I do. So I have a slightly different theory than Pat, but it points to the same thing. So if you look at the majority, can you pause it right there on that bumpy side? So if you look at the majority of this rock, it's all sharp edges, flat planes, jagged, where you could tell that it's been broken. And it's been broken in a way that glass-like igneous rocks break. My theory in how this type of formation forms on those rocks is that igneous rock was liquid at some point. And this was liquid and it came up against a solid rock. And when it cooled off, that solid rock left an imprint on that side of the rock that gives it some kind of texture that's not normal in an obsidian or some kind of lava flow. So,
Wow.
and I found this up in like northern Arizona where there's a lot of obsidian, and you'll see just these sharp edges, and then you'll just see this one side that just has this real unusual texture. And my theory with that is that that's where that cooled up against another surface.
Wow, very interesting, Chris. I'm so glad you pointed that out because I wasn't making heads or tails of this. And to know that it may not be the actual material, but it's a imprint. Yeah, absolutely. Clay putty, silly putty, if you want. Sue, thank you, Chris. What do you have, Sue?
Mine's not about the rock ID necessarily as much as the media. I just want to give Kevin a shout out. He signed up as a rock hunter, and I think it was within 18 hours he had this video and the survey all done
Wow.
without any prompting,
Yeah.
without me having to have him do the video over, which no offense to anybody that has to do their video over, most people do. But what I want to point out is look how much of the screen his rock is taking up. We have so many videos where we get it and I look and I'm like, wow, the rock's not even taking up 10% of the screen. If you're gonna be a rock hunter and support us and you want us to look at your rock, use your entire screen so we can see the rock up close just like this. This is perfect.
Yeah, thank you, Sue. And I do want to touch on the last subject that the submitter said, hey, found it in his yard. It wasn't there yesterday. We're stumped. You know, we weren't there. We don't know. The only thing I can think of is, well, see, obsidian wouldn't have a magnet stick to it, so it kind of fits in with what we're saying as well. The only way it could be a down tree and a new rock and be related in my expectations with this as your sample would be if this was underneath your tree and was upset when the tree fell and now this is visible. I don't know if that correlates to the way it was found, but that's what I think about it. Unless one of your neighbors threw it over the wall at you. So the crew consensus on this one is we firmly believe this is a terrestrial sample. We heard igneous rock, we heard obsidian. There was a lot of conchoidal fractures, shiny glass sides. If meteorites looked like that, we wouldn't have to cut and slice and polish them. They look beautiful on the outside. So no, I think we are all in agreement that it's a very interesting rock. You probably heard a little bit more excitement about that rock than most of them. We were very interested, and as Sue said, good media, so we were able to work with it. Thank you very much. But it's terrestrial. Sorry. Want to give it a big shout out. Thank you to all of our supporters on Patreon and on YouTube. You can be a subscriber to the channel, but you can also be a member on YouTube and a paid member on Patreon. There's different membership levels. Go out and join Patreon for free. You get access to a little bit of the stuff. You see what's going on. You can add to the conversation. But it really opens up when you pay $10 a month. You get access to what is now a few years of backlogged videos that weren't available for the people who signed up when we first did the Patreon. So you join now and you get 2 years worth of videos for the first month, basically. So you don't have to wait 2 years for them like the original people did. But we definitely appreciate all of our supporters.
It's not 2 years, it's 3 years.
Wow.
Art became our first supporter in August of 2023.
Yeah. The Ozerki Turkey was our first one. And yeah, and what's great now is, as I said, we do have free membership status on Patreon. It doesn't give you everything, but it allows you to dip your toes in the pool. We have over 300 people now or something like that.
Almost 400.
Almost 4. And Sue is very active there of posting trivia, posting
Meeting
rock
summaries.
rock ID challenges. All you could literally go out there as a free member and get the entire summary of our hangout, stuff that didn't even make the recording, and you can see a written summary all logically laid out, And you know what? There's a tool that you can have it read it to you, so you don't even have to look at your screen. So that's what I do. Um, thank you very much, Sue.
Our third rock hounder of the night is Eric. I do want to give a shout out to Christina. She actually was the one that signed up and been communicating with her, but Eric filled out the survey and she said Eric was the one that found the specimen, so she wanted him to be on the screen, but I'm giving her a shout out anyways. All right, so as I mentioned, Eric, new supporter. This was a specimen found in Northwest Pennsylvania in a place called Duke Center. He did report it was about a quarter of a pound, but I did remember to convert it to grams for this one. So about 115 grams. And he actually found it during the winter time and it put a tiny hole in his roof. So very interesting. Okay, so we always have our rock counters do some diagnostic testing. This one, the magnet test was performed on camera. The streak test was not, but we do have a photo of it.
Yep.
And the streak test was produced a light gray streak, weak attraction of the magnet. We always ask our rockhound supporters to report what they see as far as meteoritic features. Eric reported an unusual shape, shiny metal flecks, and in that other category, he added black and reddish color. And I will say this specimen seems like some of the photos, it looks almost like different rocks. So I think it's like black on one side and like a totally different colored texture on the other side. We always ask our supporters to take a guess at what kind of meteorite they think their specimen is. And I've not had anyone answer this before, but Eric believes that his specimen is a meteorite from the asteroid belt. So I don't know if that's a HED or just a general asteroid.
No, I like the way he hedges his bets there.
Yeah, he's keeping it open.
No, because odds are it's
That
not
was
from the
very
moon.
tricky.
Yeah, it's not from the moon. It's not from Mars. Hey, man, asteroid belt. Yeah, let's hope so. Here we go. Well, we're going to take a look at it. We're right back. All right, the crew has looked at these, and we've had fisticuffs. Yes, we've formed alliances. No, we don't all necessarily agree on what it is, based on not having it in our hands, knowing that it supposedly fell onto a roof. That limits what we can assume it is. But we had two different camps necessarily talking about these. I immediately when I saw this, because I just got through spending a lot of time on my slag presentation videos on the channel. This looked like slag to me. The color was unique, and I think Dave Pinsky, you were going to mention something about the color on this one.
Yes, the interior on the one that you see on the screen on the left is not something I usually see in a meteorite, whether it's an achondrite or chondrite. It just has this brownish reddish color that puts me in a little bit in the camp of slag, because also the coating could be a material that just melted in a different layer on top of it.
Okay, so that's you and me in the slag camp. We're gonna be sharpening our sporks in the corner. Art, captain of the other team. What are you seeing when you saw this?
Well, I was looking at two different lithologies, and I was tending to believe that this might have been a metamorphic rock, but when I heard that it put a hole in the guy's roof, it was a little hard to wrap my head around.
Yep.
But that reddish color is very common again with slag, but also volcanic rhyolite. And that rhyolite is a volcanic ash, and it can be red, green, or multiple colors. So, but I'm not seeing this as a meteorite.
Okay, thank you, man. I appreciate it. And this, like one of the other samples we looked at, looks two-faced. It has. If you showed me these, I would not tell you, oh, we're looking at the exact same rock. I would think these are different. The scratch test didn't really reveal a dark, I can only assume that it's these lines here. It's kind of brownish, tannish, so it's not a real deep red or black magnetite like kind of like what we expect. No one thinks it's magnetite. Anthony, you want to talk about what you're seeing on the outside?
Yeah, sure. So, if this, was a meteorite and it did hit this guy's roof, you would expect the shape to be a bit more smoother on the outside. It does look like it has like some flow to it, but that's not really consistent with like flow lines that you would find on a meteorite. And like, okay, if this is the exterior and the interior of the rock, right, we shouldn't be seeing vesicles in the crust, right? That's kind of a dead giveaway for me. So I'm leaning towards slag. I don't know how it would have got on a roof. It does kind of look like asphalt, as Jules pointed out in the chat. So that's what I'm leaning towards.
Thank you, man. I appreciate that. We were looking at this from a certain way, and one of our crew members said, "Look, if you squint, you can see flow." And they're not joking. You can actually see some orientation, some flow, orientation of features. But as Anthony was pointing out, we got to look at where they are on the rock, and the flow lines will be coming over the top of it. And Pat, you were mentioning on this side here, you were literally seeing this top part a lot more porous, and the vesicles not being as round as you want on
Exactly.
on
Yes.
meteorites.
Yeah, yeah. So we can see a fair amount of porosity there. The sun hits just right, so the pores are dark colored, and they're not spherical. And uh, vesicles in meteorites are extremely rare, but when we do see them, they're virtually always a sphere. And the sharp edge here at the top, that's not right for a freshly fallen meteorite. Uh, Also, the
To
colors,
me,
they were mentioned. Sorry?
I want to, I'm sorry, on this angle right here, because we were talking about what could it be, how could it be formed. And if you look at the bottom of it around here, imagine this was like, this obviously looks like the flat top, a flat side. If you had it in a flat bin and you poured it out, it would have this skin on it. If you poured it in the ground in dirt, this would seep in and you'd have this uneven edge, some aeration in there, and a smooth top. So I'm just explaining what I see, but I thought this was a very good angle. Pat?
Yeah, yeah. So, and also, we're not seeing anything that remotely looks like a chondrule. And those two colors are pretty classic for slag. We
Mhm.
talked about the vesicles, we talked about the sharp edge, but we have to remember. So, I'm going to argue this is probably a piece of slag just because of the general appearance of it. And slag gets used for road base, rock paths, crushed rock, anything, fill dirt. And we know that lawnmowers launch rocks, tree chippers will launch rocks, and in areas where there's a large area to mow, like alongside a freeway, they use a mower called a flail mower, and they're famous for throwing rocks. So I suspect that this is from the side of the road thrown onto the roof as a piece of smelting slag.
Thank you. I appreciate that. And I'm going to piggyback on one thing that Anthony was talking about. If this was a meteorite that did, I mean, if it was on your house, we can assume it fell in the last 10 years. Okay. Probably hasn't been there more than 10 years. This does not look like a 10-year-old meteorite to us. This, a meteorite that fell 10 years ago and it's been sitting on your roof, getting lightly rained on for 10 minor years, that's nothing. That's a blink of the eye geologically for this thing. It would look as fresh as day one. We have hunters who go out to Holbrook and find Holbrook peas on the ground. They fell in 1912. They look brand new. So you would not see this much terrestrialization or this much wear. You would see recognizable fusion crust. All right. Well, hopefully we weren't too excited to share our negative feedback with you, but these were good samples today. I thought we had some different looks at rocks from one side, and it looks one way, one side it looks another way. We don't all. I purposely put in here differing opinions to let you know that we don't know everything. We're not lording it over you. We're literally sharing our opinions and telling you what we see from our experience. And literally, is it worth taking the next step? Is it worth spending money on? Is it worth spending more time on and obsessing on? And this sample is a hard no. We're going to stop recording, and we're going to now just hang out as friends without you guys watching us, you stalkers, lingerers. All right, goodbye. Thanks a lot, everyone. Have a good week.